We're going to continue looking at graphs, but we're going to specifically look at time-distance relationships. And in this case, more so dealing with a motion sensor. So when we say a motion sensor, we're saying like, okay, there's like this motion sensor thing set up right here, and let's just say it's at 0 feet, right? And then you have a person, and let's say, I'm just going to put my distance in feet, so like 1, 2, 3, 4, 5, like that. Okay, so 1, my distance is going to be in feet, 2, 3, 4, 5. So let's just say my person is standing 2 feet away. I'm going to put a dot right there. That means really at 2 feet away in real life, there's a person standing away from that motion sensor. And then we're going to talk about how the person walks, whether they will move further away from the motion sensor or closer to this motion sensor. Should put little sensors on this guy. There we go. Got some sensors. Cool stuff. All right, and now what we're going to deal with, we'll look at like in terms of seconds probably. So like, let's go seconds. 1, 2, 3, 4, 5, 6. So for example, let's say in 1 second my guy goes to 3 feet away, right? Let's say he walks to 3 feet in a second. That means my graph would look like this. There'd be a dot up here at 3. It'd be moving just like that if he moved at a constant rate. Okay, he could also move closer to the sensor. What if he walked all the way to the sensor within 2 seconds? So we went from 3 feet all the way to the sensor within 2 seconds. So that means he would go from 1 to 3 seconds all the way, boom, to the sensor just like that. Okay, and he could even stand next to the sensor for 2 seconds and then move a foot away again in the next second. Things like that. That's what we're talking about with a time-distance relationship. Okay, so let's look at some examples with that. So it says, describe how someone would walk this line here. So you can make up some information if you want. Well, we got this. We got feet. We got seconds. So here's 1, 2, so on and so forth. And we got 1, 2, 3, 4 feet. All right. So you would say the person started at how many feet away? So right here, 2 feet away. So the person starts 2 feet away. Oh, let's be specific, from the sensor. And let's see what happens from the first 2 seconds. It looks like they walk at, do they start slow and walk fast, or they start fast and walk slow, or do they walk at a constant speed? Yeah, this is a constant speed, right, if it's a straight line. So you could say started 2 feet away from the sensor and walked 2 more feet from sensor at a constant speed. It's kind of important to say at the constant speed because it didn't increase its speed, it didn't decrease, it went at a constant speed in the next 2 seconds, in 2 seconds, basically. Okay, and then what happened after 2 seconds? Well, in the next 1 second, it traveled 3 feet towards the sensor. And was the speed faster or slower than the first 2 seconds? Well, they only covered 2 feet in 2 seconds. Now they're covering 3 feet in 1 second. So really they went at a faster constant speed. So the person walked towards the sensor now at a faster constant rate and traveled how many feet? 3 feet in 1 second. And then lastly, the person kept moving towards the sensor but slowed their rate. So the person kept moving at a slower constant. And you could say, and reached the sensor in 2 seconds, in 2 more seconds. And reached the... Okay, so I was very specific in how I described this. I don't expect you to be as specific, right? I wrote about like the constant rates. If you don't have that's okay. Like if you said the person started 2 feet away and traveled 2 more feet further away in 2 seconds, and then they traveled 3 feet closer to the sensor in a second, that's just fine by me. But I wanted to be specific so we could really see what these graphs mean. Because we haven't talked a whole lot about rates yet. So if you don't have the stuff about the constant speed, that's just fine, right? If you leave that out, that's just fine for now because we haven't got too much in depth with that. Well, can we write a recursive routine for something like this? Sure. Remember recursive routine? We just put where it starts and what the rule is. So where does this guy start? This guy starts at 1, 2, 3, 4, 5, 6 feet. So we say 6 feet. And let's see, it goes in 1 second, it went down how much? Looks like 2 feet, right? It went down 2 feet. So that's going to be a -2. So we subtract 2 feet each time. So there we go. There's our rule. Starts at 6 feet, subtracts 2 feet. All right, so now let's make a graph when we're given something. It says start at the 0.5 meter mark and walk at a steady 0.25 meter per second for 6 seconds. So here's kind of your constant rate that we talked about. Steady, right? Steady. It's not increasing or decreasing. So I should probably put my 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my 6 seconds. 1, 2, 3, 4, 5, 6. All right, so it says we start at the 0.5 meter mark, so that's right here. And then we go 0.25 meters per second. So 0.25 each second. I might even want to make a table just to help me out here. So at 0 seconds, we started at 0.5 feet, right? I can even put that. Seconds is on my x's, feet is on my y. So in 1 second, we added 0.25. So really, we're at 0.75. At 2 seconds, we should be at 1, right? And 3 seconds, we should be at 1.25, so on and so forth. So that table might be helpful. So at 1 second, we're at 0.75. At 2 seconds, we're at 1. Okay, so on and so forth. And so at 3, we're at 1.25. 4, we're at 1.5. Okay, right there. And 6, we're at 2 feet. So this should be 6 seconds is at 2 feet right here. And then I can draw in my, if it's a steady rate, it should be a straight line just like that. And it looks like we didn't move any closer to the sensor. We didn't increase or decrease our speed. So that looks perfect. All right, now let's write a setting watching directions, kind of like we did back here with this table. So we're going to start where? Start at the 4 meter mark. Right, I can see that right here. That's where we're starting, 4 meters, and I can tell it's meters. And then what's happening? We're decreasing. We're traveling, how many meters per second? It looks like 0.4, right, every single time. And are we going closer to the sensor or further away? Looks like we're going closer, right? So we're travel at a steady 0.4 meters per second moving towards the sensor. And how long do we do that for? It looks like for 5 seconds. For 5 seconds. Did anything else occur in there, or do we just keep dropping 0.4? It looks like we keep doing that. Just be careful. It might change and turn directions or move at a faster rate, but in this case, we just want a steady 0.4 meters per second moving towards the sensor for 5 seconds. Okay, so just look closely at your table and write out some sentences to describe that. So hopefully we kind of got a good grasp of what our graphs look like with distance and time relationship.